and I do record all of my lectures, and I do post them up to D2L Brightspace upon completion of class, along with any printed notes and stuff that we do in class. There's some professors that might go to the other extreme and they have pre-packaged notes or whatever they sell as a packet or whatever in the bookstore. That's not me. Me is presenting the stuff in class and then putting it up afterwards. And so again, what you'll see me post to D2L after class will be all recorded lectures. Anything that you see and write on the screen as we go through, for example, I write with my tablet PC here, will be stuff that will be showing up when those notes are posted. So, that said, coming in here today, if you were in here early, you saw these notes, you were to pick up a course syllabus and then pick up a pink card with an element of your choice, and then you were also to download and install the Socrative student app to your smartphone or tablet device. If you don't have a smartphone or tablet device and have a laptop, you can bring that in and have it logged into www.socrative.com. If you do not have any sort of mobile device, talk to me after class and I'll see what I can set you up with. We do have a few laptops here that belong to the department, one that you may use. But what I do wind up using the Socrative app for is a couple things. It's a quizzing clicker type tool where you'll see it in action here today. We'll be surveying the class, asking some questions and such, and can also use it to, I use it as an assessment to see how students are doing with the learning at that point. And if we're doing well collectively as a class, I choose to go on. If we're not doing well collectively as a class, we'll talk about why we're not doing well, and I'll spend more time with it. Now, if you were in here earlier, I was asking to make sure that we could log on to the Wi-Fi network. This box up on the ceiling here is the high-density Wi-Fi platform. This is the first semester that that is being used. Last time I taught in here, the Wi-Fi was so bad and the cell signals were bad that we couldn't do this Socrative type stuff. And so we'll see here how it goes today, and if we can all use this high-density Wi-Fi, then we'll continue using it as a part of our class. So that said, what we'll be doing today is going through the syllabus a bit, and then talk about some of the expectations that we have for you for the semester, and then go on to some introductory material. I'm just curious, because I think most of you have been through your first classes already. For how many of you is this the first class you are attending this semester? All right, so you don't need me to go through the syllabus and everything. You know there's going to be rules, there's going to be expectations, there's going to be due dates and assignments and such. You don't need me to read through the syllabus and whatever else. I do, however, would like to highlight a few things so you know how my syllabus is kind of laid out, and kind of go from there. So if you could get your syllabus out, and if you came in, syllabus, who needs one? There's 1, 2, 3 of you here. And we need each one of these a pink index card. Okay. You can also see that if you wind up coming late to this class, we are packed in here like sardines, so it's not easy finding a seat, especially if these are the ones that are left. I like to say, when not every seat is taken, that if you do come in late, that you find a seat in the back. If possible, but obviously if these are the only seats available, you have no choice. But that said then, if people want to leave these seats open then, what I do ask is that you do strive to make it here on time, because it is distracting and whatever else when we come in late. And if we do have seats available, I would prefer that you, very much prefer, that you find a seat here in the back. Prerequisites are listed here, office hours are listed, the lab managers are listed. What we probably on this first page would like to be most aware of is the lab professors. I am teaching the lecture portion of this course. Somebody else is teaching the laboratory portion of this course. We have 48 people that are attending lecture here together. We split up into 2 groups for lab. half of you will be working with Howard Creel. Howard has lab today, 2 o'clock, right after this class. And Patty Pieper, you'll need to tell me when this is. I think it's Wednesdays. Yes? At what time? 11 o'clock? So the other half of you then will have lab with Patty at 11 o'clock tomorrow. And that's on a weekly basis. So again, Tuesday, Thursday is in this room with me, and then lab is either with Howard Creel or with Patty Pieper in room S220 every Tuesday or Wednesday, depending upon which professor you have. Now, what I will say is that these people aren't like my lab assistants or whatever else. These people are my colleagues. They are my teaching colleagues. They're every bit as much part of teaching this course as am I. At the end, I am the one that assigns the grade to this course, but I wind up assigning that grade based on consultation with my colleagues that are teaching this course as well. So they should not be treated as any lesser of people or whatever else, because they have an equal share in determining how the course grades are assigned. It just turns out that the lecture person is the one that winds up assigning the grades. So that said, when it comes to assigning grades, I will be wanting to know about your laboratory performance, and they want to know about your lecture performance. So if things are going in lab where it's like, wow, this person's really great, how is he or she doing in lecture? We share that because we are team teachers. If they're doing really poorly in class, they come to me and it's like, wow, so-and-so is just not doing so well. How is he or she doing in lecture? We talk about that because, again, we are team teachers as a part of this course. But in the end, since I am the one assigning the grade, it's going to come down to things where what is your lab score? And the question I am going to ask when I get those lab scores is, did this person attend every lab? Because laboratory attendance is mandatory as a part of this course. This is a laboratory-based course, and presumably you are in here because you are pursuing some sort of STEM major, whether it's something in chemistry or engineering or medicine or pharmacy or whatever else. The reason why you're in here is because you're pursuing something presumably related to that. Consequently, you need hands-on experience in the lab, and if you are not there to perform the laboratory activities, your grade is going to suffer accordingly. So, as a department, we have a policy which says that if you miss 3 labs in this course, even if you have an A in the class, if you miss 3 labs, you're going to drop 1 full letter grade. If you miss 4 labs, you're going to drop 2 full letter grades, and if you miss 5 or more labs, you will fail the course. In fact, once you get up to 5 missed labs, if I am aware of it, or your professor, either Patty Pieper or Howard Creel is aware of it, we will pretty much recommend that you just drop the course to spare us the agony of having to assign you an F to this course. So again, laboratory attendance is required. Now, as far as your attendance here in lecture goes, that attendance is really up to you. I see a few faces of students who've had me in here before. Where are we at? Attendance, what would you say?
I showed up to every class.
Yeah, showed up to every class. And those that didn't, what happens?
They slowly disappeared.
They slowly disappear, exactly. And that slowly disappearing is largely due to the fact that they get very poor grades. So even though I do post all my notes to D2L, both my video recordings and my PDF copies of my written notes, you know, if you think it's boring to come here and be a part of this class for 75 minutes twice a week, just try listening to those recordings of classes before you're trying to go to bed or whatever else. Guaranteed to put you to sleep. All right, so you will want to make sure that you do attend class here on a regular basis. So that said, I don't take attendance in here. However, that said, we are going to be using the Socrative app as a quizzing tool feature, and when we go through it, even though you'll see on the screen that we won't see your name or anything else associated with it up here, I know who you are because you'll be signing in, And if it gets to the point where you take an exam, you do very poorly, and by poorly I mean like 30 or 40%, and I say, oh, but I worked so hard in this class, and I was there every day, and I see no record of you ever signing into the Socrative app, that's a pretty good indication you weren't here. And you're going to also develop your favorite seats in here, and even though I don't know your names yet, and I won't be having you for lab, my goal is to learn your names so I know who you are, and whenever there's a hole in your favorite seat, a hole there and you're not around, I begin to realize that you're not coming to class regularly. So even though it's not something that I take attendance on a regular basis, I do wind up seeing whether you're here or not. Now, how many of you got the copy of the syllabus before the semester began? Okay, and those that didn't, can you tell them where did you get that syllabus?
Oh, email.
It's called email, yes. So, and how did I know your email address? Well, everybody here has an Anoka Ramsey email address. If you didn't know that yet, now you do. You have an Anoka Ramsey email address, and I emailed the entire class here a week before class started to let you know what the syllabus is, what we'll be doing during the semester, when the exams are, and all that stuff. So you received a copy of that already, and if you haven't checked your email yet, you probably ought to check your email, because if there's some communication that's going to take place as a part of that class, that is the email that I use as your ARCC assigned email address. So part of that then was to talk about the textbook options. And we had a meeting with our textbook rep last spring, and we worked out a really good deal here. You're not going to, honestly, you won't find this anywhere else. But we worked out a deal with our textbook rep to have you access both your textbook and Master in Chemistry for $59.95 for this semester. Now, where that's a good deal is this. How many are planning only to take one semester of this sequence? There's a two semester sequence. How many just plan to take one? Raise your hands. Okay? So if you just need one semester, instead of having to buy a textbook with access for 18 months like we've had to do in the past, we worked out a deal where you can get access for 6 months, and it's at about 1/4 of the cost of the new. In fact, the new textbook, if we got a hardcover one from the company, we'd be paying about $300 for that. So the price here is $59.95. In addition, the setup that we'll be using, if you were with us for 1020 and Master in Chemistry before, we are going to be using Master in Chemistry again this semester, except we're using what's called Modified Master in Chemistry. And the Modified Master in Chemistry is a platform that is accessed through D2L, Brightspace. And so the first time that you sign into Master in Chemistry, if you've in your math classes or whatever, maybe you're using MyLab, or in biology you use Mastering Biology, I believe. The difference here when we access it through D2L is that you're going to sign in one time, and that is the time that you activate your Master in Chemistry. After that then, the course is linked to D2L, the Master in Chemistry, so you're going to log into D2L, and then when you click on the any Master in Chemistry link in there, the Master in Chemistry link will automatically log you in to Master in Chemistry. So you will not need to know, you'll need to know it for a future semester if you register for a course, but at least for this semester, you won't need to know your login credentials for Master in Chemistry except for that first time that you log in. And if you never used it before, you're going to create a user ID and whatever else that goes with it. The second thing that's going to happen is that you do have a free 14-day temporary access available if you are waiting for financial aid, which I know some of us do. I hear that all the time, and I hear from students, I can't complete the first assignments because I can't get into Master in Chemistry. Well, what this Modified Master does, because we can track who you are now through the D2L Brightspace, we can give you the 14-day temporary access, and that's just automatic. Well, it's not automatic. There's a link you have to click on that makes it automatic. But once you click on that link, then and say that you want that 14-day access, you'll have the full access that everybody else does, but you will then need to pay for that access within 14 days. The payment for access then will occur either through using PayPal or a credit or debit card at that point. But that's instead of going through our bookstore. So again, this is one option if you're only doing one semester that I very highly recommend. The option up here, this is the custom published textbook that is being sold down in the bookstore. Looks like this. There should be 2 access codes that were packaged with it. Can anybody confirm that? Yes? Okay. So those are 2 6-month access codes. If you took the course before, and I'm not going to put those people on the spot, but I know some of you in here are retaking the course and have previous access from this course. Your previous access code and login credentials for this course will not work. However, if you do have previous access, don't go out and buy new access codes. Item number 3 here under the Mastering Chemistry Access will tell you, if you are a previously registered student, how to get that access to Mastering Chemistry. So again, if you have previous access, as long as it is unexpired, you'll contact our Pearson textbook rep, Carrie Mataney, and she will verify, first of all, that you have had previous paid access, and we'll give you an access code that will work for the duration of this course. So there's a lot of stuff in there. Again, though, I assume that since you're intending to be science and engineering and whatever majors, that we need to really wrestle that right now, please. I would assume then that you would be able to follow the instructions on here. If you do need some help with getting access to the course, then talk to me or talk to our tutors, and we will get you some access to those courses. And if you do need some illustrated instructions, I put together a little PowerPoint, and you can click on that PowerPoint and it'll go step by step, depending upon which option you have, illustrated as to how you would go about accessing that Mastering Chemistry. So, any questions that you have? All right. Laboratory materials, scientific calculator. Scientific calculator that we'll be using here, you may use like a TI-83 or 84 graphing calculator. And what I will tell you though is that at the end of the semester we will be doing a standardized final exam. Standardized one is kind of like one you might take for the ACT or SAT. This standardized exam is one that has been written by the American Chemical Society, Division of Education, Division of Chemical Education. It's got a big long name. Anyhow, it's one where your performance on that exam will determine your grade for the final relative to how you perform against your peers at the national level. So, on that test, we cannot use programmable calculators. So for the final exam and final exam only, you'll need to use some non-programmable calculators. For the rest of them, if you want to use your TI-83s and 84s, that's fine, but just want to point out for the final exam will require the use of a non-programmable calculator. I do have some that are available to loan out, and we'll talk more about it at that time. Yes?
So does that mean basically just not a graphing calculator?
Oh, there's some non-graphing calculators that are programmable, but most students don't know how to use that these days anyhow, but yeah. So, but we'll talk.
I'm just trying to figure out what you mean by programmable.
Programmable would be things where you could put in things like periodic tables and names of ions and have access to the internet and stuff like that. So basically something that doesn't allow you to store all sorts of data on it. Okay, but we'll talk about the models of the calculators here towards the end. But for the calculators here on the upcoming exams, hour-long exams, your TI-81s, 84s, if you have them, will be fine to use. Smartphones and smartwatches and stuff like that are not fair game for those exams. Laboratory materials, those are ones that are going to be delivered via our website, and you'll also find the link through D2L in your lab course. One thing I should mention here is that if you go into D2L, let's see here if I have a D2L page up. Here we go. When you log into your D2L, you are going to see that you have both a lecture course and a laboratory course. So anything associated with lecture is going to be, I'll be populating this one here. Anything associated with lab, you'll find this course here populated with that information. So you will be using two different D2L courses. Part of it is because you have two different instructors, one for lecture, one for lab. So anything lab associated you will find in the laboratory portion of the course. The one thing you will need is a bound lab notebook. And I think I just took those all off of my cart, but anybody happen to have a bound, like a composition book or anything with you right now, so I could give an example of what a bound notebook looks like? Composition. That one, if it has tear out sheets. This one would probably borderline no.
Okay.
The composition by bound would be something like this, one of these composition books. Bound, you'll probably see some threads or something in here somewhere. Part of the reason for that is that since you are planning these professional careers in the sciences, record keeping is an important part of all of the sciences. And today, of course, when we see the debates occurring at the national level about, well, is there climate change or is there not climate change? And we look at data and so forth. Your data that you collect is going to be your proof that you actually have that stuff available. And so if you have something, though, that has easy tear-out sheets, your lab notebook says it's supposed to have 80 sheets in it, and they go through and find 79 sheets in it, I know what happened to that 80th sheet that's in there. What data are you trying to hide, whatever. So, but again, that'll be something you'll talk about in lab. But do want to point out here that you do need a lab notebook for this course, and your lab teacher will talk a bit about that. Conduct and attendance we talked about. Assignments and quizzes. We'll find these elsewhere in the syllabus. So I believe this will be page 8. There we go. Page 8 has a summary of the stuff you should be reading from the text, and it is organized by exams. So exams 1, 2, 3, and so forth. You can see what will be covered on each of the exams. Over here, you'll see that there's some end of chapter suggested problems. I don't collect these from you at all. But if you're not doing the suggested problems, just like we talked about attendance, your chance of success in this course diminishes greatly. In fact, if you're comparing performance of 10-20, if you took it here before, or high school chemistry versus this course, maybe you got by with doing little homework in those intro courses. You're not going to get by with doing little homework in here. Students that do little homework in here, their history of performance in this course is not very good. So these are ones that I recommend doing, and I recommend these because these are ones that will be reflected in the exams that you'll be taking in this course. So if you go through these and you can do these no problem, there shouldn't be any, and when I say no problem, that means without looking up answers in the back or whatever, then your performance on the exams should be no problem. Now, to give you a little bit of an incentive to do this work, I will show you where that incentive lies. And this is going to be in your modified Mastering Chemistry. So you're going to go to access Mastering Chemistry in this course. You'll click on the Materials menu, then on Content, and then you'll see a link to the Modified Mastering Chemistry here. You'll see other links to Mastering Chemistry Extra Credit and homework quizzes. But you'll click on this link, and then you'll go on the Pearson MyLab and Mastering, and this will then open up, clicking on this link will open up Mastering Chemistry for you. Once you get in here, you'll be able to see the list of assignments over here. And as this loads up, you're going to see that there's two different types of assignments that are shown. You're going to see some that are called practice A and B, and then homework quiz. Now the practice questions, those are for extra credit. And the practice questions, those are the same questions as the ones that are listed right here. So provided, I've incentivized the practicing a little bit by putting it for extra credit. It's not a lot. It's not a lot. In order to get the extra credit, you have to complete them on time, and you have to achieve a score of 80% or better. But if you complete them on time with a score of 80% or better, then you receive half an extra credit point for every one that you complete on time with a score of 80% or better. But if you look through here and you see how many A's and B's there are going through this list, you'll begin to see that there's a whole bunch of them, and those little half points here and there begin to add up over time. So you don't want to put them aside because they're only half a point. Again, that half point adds up, and that is extra credit, bonus points, whatever, that goes on top of your other points. And then there's the homework quizzes. The homework quizzes are going to be worth 5 points apiece. Now you go on there and you say, well, wait a minute, I clicked on this link and it actually says it's worth 107 points, or it's worth 2 is worth 85 points. Okay, well, what I do to arrive at the grade is that the grades get exported into D2L as a percentage, and then those percentages are converted over to a score out of 5 points. So if on homework quiz 2 here, you wind up scoring 80% out of 5 points, that would be equivalent to 4 points. So in the D2L gradebook, you would see a score of 4 out of 5. Regardless of whether it shows 120 points or 87 points or whatever it is. If you want to get an idea what those 127 points or 85 points or whatever stand for on those homework quizzes, here's what they mean. A quiz that's worth 87 points on mastering chemistry, or shows that it's worth 87 points, is one that should take you on the average 87 minutes. So what I did is that I assigned a number of problems, and let's just look at one of these here, homework quiz 1. Look at the student view, and we'll talk about the differing number of points. It's like this is worth 1 point, this is worth 9 points, this is worth 7 points. What I did is I took the national average, because this is a national platform here, and took the average time of all of the people that took it. I mean, there's tens of thousands, if not hundreds of thousands, that have taken this by now. And if on the average it took 7 minutes, I made this one worth 7 points. If on the average it took your peers at the national level only 1 minute, then it's worth 1 point. So when you look at these in advance, it's kind of going to give you on the average about how much time each one is going to take on the average, based on all the hundreds and thousands of people that took it before you. So any questions on the setup for points on mastering chemistry? Okay, let's look at the syllabus, just see. I'm trying to not do everything. Okay, exams and other due dates. There's a calendar in your packet. This calendar shows all of the due dates for the semester. On here, of course, if you view it online, you're going to see it in color. The red ones here represent mastering chemistry homework quizzes. These ones here that are in this purple color, these represent the practice problems that are on mastering chemistry and worth extra credit. And then you have your exams that are listed here as well. Just a quick heads up on exams, and again, this is all in the syllabus. Your attendance at exams is required. I don't put myself in the business to listening to excuses. I mean, I'm sorry if you are sick or whatever, or have a flat tire, and I'm not trying to tell you I don't care. I do care. But the exams will be on these dates, regardless of what's going on in your life on those dates. What I do is this, is that if we don't quite finish material, like the chapter 4 material, then maybe it won't show up on exam 2. But you can, I say I value your time, and you can put these in your calendars right now and count on these as being the dates because I respect your time and your busy schedules and whatever else. So you put them in there, and the anticipated coverage though will be the chapters or whatever materials that are listed in there. And if we don't have time to get to something, if it's not important, I try judging time, whatever, I just don't put it on those exams. Now, I am required to allow makeups, or required? Yes. Required? Yeah, I guess that's the right word. I have to do makeups for 2 reasons. Those 2 reasons are if you have a conflict with a school-sponsored event or activity, I have to allow a makeup. And if there's a conflict with any sincerely held religious beliefs or events, I have to provide an opportunity for makeup. If you have a sincerely held religious belief, you know what those beliefs are today, and you can tell me today what those conflicts are. If I don't hear them today or this week, I'll assume you don't have conflicts. It might be for school activities. Do ask that you let me know 2 weeks in advance of any conflicts you may have with school activities that would conflict with an exam. But if makeups are given for those reasons, they're always going to be early makeups, never a late makeup. So again, those are the only makeups that are possible, and they will need to be early. This is your schedule for labs. This was edited. This is different than what is in your packet, I think. Certainly different than the one that I emailed out. And what's different about it is these 3 weeks right here, and it's the one that affects you guys. So there was some talk this summer between the colleagues. We weren't able to get in touch with everyone to see what that schedule was, so we guessed based on a previous schedule. And after the schedules were published and went to print, then we got together with Professor Creel and Pieper and agreed to this change. And I think you'll like this better because instead of doing 2 labs the first week, intro safety and then the spreadsheet 1 lab, we've spread those out. So the intro and safety is going to be week 1, the spreadsheet 2 will be week 2, and then the microscale where it lists Q&A on your packet will be the microscale lab. So please take note of the changes in here, that we will be spreading those out over the 3 weeks rather than 2. And certainly once you get in there today and next week, especially if you've never done spreadsheets before, you're going to be very thankful of the extra time you have to do that spreadsheet lab in lab. Okay? So other than that, everything that is in your syllabus packet should be the same. There's a place for you to keep track of your grades. And then at the very end, there is your first quiz, your first assignment. And this is a syllabus quiz. So this syllabus quiz is one that you will be sending from your ARCC assigned email address. Not from your Gmail address, not from your Yahoo address, not from your Hotmail. It's going to come from your ARCC assigned email address. When you send it, you're going to put in this subject line right here. And if you're concerned about your ability to type this correctly or spell it correctly, just copy and paste the subject line into your email and then write an email to me. When you do that, this is going to be the information that you will be required to put, and then you're going to send it to my email address right here. You must do this by Thursday, August 31st at 11:59 p.m. If you send that email to me, as long as my computer is turned on, my computer is going to send you an automatic reply saying, yeah, I received your email. You can go ahead and take the syllabus quiz on D2L. Now, there's sometimes, I might actually have my email closed right now, but there'll be some times where I am in transit between here and home, or my computer won't be hooked up to network anywhere. At that point, automatic replies aren't going to occur. But as soon as I get home, I'll open up my laptop, hook it up to the network, and then a reply will be generated to you. Once you receive that reply, you can go on to D2L Brightspace and take the syllabus quiz that is waiting for you. This has to be completed by Friday, September 1st at 11:59 p.m. So, with that, this is the syllabus. We didn't cover everything. are there any questions that you have on the syllabus or the expectations? Any questions? Yes, sir.
So when I was in the bookstore, I noticed that there were optional books, and so there's study guides there. How much would you recommend to get those study guides?
Okay, my recommendation in the study guides, there's 3 levels that are asked of us as professors when we put textbook requests forward. 1 is required, 1 is recommended, and 1 is optional. The fact that these are labeled as optional should say something. They're neither required nor recommended, but there's something that sometimes students will say, you know what, I want whatever resource available to me that I can. To that, I would reply, one of the things that I've done is I teach some online chemistry courses, not for this level course, the 1061, but I teach an introductory chemistry course, and that introductory chemistry course is online. On one of my sabbaticals here about 7 or 8 years ago, I did a project where I recorded a number of videos. And so, for example, if you go in here, you're going to see that there's some items for various dates. These are the dates that correspond to the dates that we meet in here. So for August 22nd, which is today, you'll see that there's already information in there. I'll click on that. There's a link called Supplements and Quick Checks. If you go in there, there are some additional pieces of information that you can use, some videos that go through some additional stuff for you. Now, these are things that are, and I don't know about the sound here because I normally teach in the other room, so you may not be able to hear this.
This is an introduction
How
to
about
significant figures.
It's kind of.
Let's start by looking at some measurements made
So
by stepping
it
onto a
goes
scale
through,
3 different
kind of
times.
Introductory example on these, and what I will say is that this is at an introductory level, not at the majors level like we're in right here. But for those of you that might miss class or whatever and want to go through stuff, usually what people are missing is the very basic introductory level, and so these get you started. And so I have some videos in there, and in addition, you'll see as you go further on down in the course, there's things that I label as quick checks, and those quick checks will enable you to, well, here's one. Click on the quick check. It will have on there a document where it asks you a number of questions. Then it's going to go through a video where it'll talk about how those should be answered. And then you go to the next page and it's going to have those solutions shown for you. So what I would say then to answer it, I know in a long way, is that there already is a bunch of extra stuff that's available. So I would say that take a look at that extra stuff that's available here first within D2L or elsewhere on the web, and then if that's not sufficient for extra help, then consider the additional items in the bookstore.
Okay. Thank
Okay?
you.
Yeah, anybody else? All right, going once, twice. Okay, if you've not yet done so, get the Socrative app downloaded onto your phones, and we need to log into the Socrative app. So here's what we're going to do. Now everybody needs a pink card. Anybody not get a pink card? Everybody needs one. All right, so here's what we're going to do. Write your name underneath the atomic symbol on this card. And write it legibly because I want to keep track of who you are. So first and last name. First and last name. And I'm going to collect this pink card from you, but before I collect it, you need to look at that atomic symbol. Look at that atomic symbol, and you need to know that symbol, so write that symbol down somewhere. Put it on your syllabus, put it on your smartphone, text it to yourself. Write that symbol down that's on there. Because that symbol is your name in this class. Yes, sir? Okay. and that is your name. Whatever that symbol is your name according to Socratic. Now, that's not the first thing you're going to enter in. The first thing here that it asks for is enter a room name. Is that what it says? Enter room name. Okay, now, are we all hooked up? Anybody having trouble connecting? Okay, maybe just one. All right, so that's a much improvement because when I asked that last time I taught in this room, 47 of the 48 hands went up. So, the room name, and this will always be the room name. You might as well write this down so you don't forget it. The room name every time is Chem Lancer. Chem Lancer, which Lancer comes from my name. If you want to know what, I didn't talk about this yet. If you want to know what to call me, I just ask if you call me by name. And my name isn't teacher or professor. My name is Lance or Mr. Lund or Professor Lund. Whatever you're comfortable with, but I'm going to do my best to learn your names. And so if there's 48 of you having to learn one name here, there's one of me having to learn 48 of you. So if you take 48 times 48, that's how many times more difficult my job is than yours. All right? So, learn my name. It's Lance or Mr. Lund or Professor Lund, whatever you're comfortable with. So when you come in every day, the room name is going to be Chem Lancer. Then it's going to ask for your name. It's going to say enter last comma first. Don't put in last comma first. Your name, according to Socratic, is going to be your symbol. So don't put in first name, last name. If your symbol is this isn't yours, but if it's say it's PD, then you'd put in PD as your name. So don't put in your first name, last name. Always put in your atomic symbol for your name. Now, I understand there may be problems here this first day. I'm not here to sort out like I can't access or whatever else. I can do that maybe after class to help you out or whatever. But for today, we'll just kind of go along. Now, in this quizzing tool, what I'm going to do is try to guide you through some answers and how to go about this. And first thing I'm going to do is I'm going to put this burette stand out here, and I have a couple different liquids in this burette, and I lost both my stoppers, so we'll put them in here. And I feel myself getting a little sweaty here today, so this does not always work the best when it's humid, but it generally works. And now I need to remember which, I think I have this set up right because I didn't check that beforehand either. Now I need a balloon. And somewhere here I think I put some balloons. Here we go. Now before we answer these questions, I actually have these questions listed on my tablet here. And no, it's not that one. Okay, it's not that one either. Okay, so I have it right on Socratic. So first one's going to be is which one of these burettes do you think contains water?
The right one.
Now, to do this, I'm going to take this balloon and I'm going to put these two beakers underneath. And we're going to run some liquid down, and I don't know how well you can see this from your vantage point, but if you can't see, try to get in a point where you can. And I'm going to, oh, that does leaking. How about that? I don't think my hair is that spiky. All right.
Try again. This morning?
Hmm?
Too much hair gel this morning?
I don't know. We'll try it again. I want that to be funny if I puncture another balloon. All right. So we'll rub this in my hair here, and we'll put it up next to this first one. Doesn't look like anything too fun's happening with this one here. So we'll go to this burette, and we'll put the balloon up next to this one. Now, can you see what's happening to the liquid on this one?
Yeah.
It's bending towards the balloon, all right? So the question is then, which one of these burettes contains water? Is it the one here on your left, this first one, which is not bending towards the balloon, or is it this one here on your right where the water or liquid or whatever we have in here is bending towards the balloon? So check it out. Is it the first one, the one that doesn't bend, the liquid or water, whatever it is, or the second one? And talk with a neighbor if you need to or want to. Which one do you think it is?
Right one.
The red one?
Yeah. So that's one.
I don't think water would move.
All right, get your answers locked in here, please. And we're going to count down 5, 4, 3, 2, 1. And it is the second one. Now, was it the fact that I accidentally let it slip out, or? Okay. Why would it be the second one? What would indicate? Obviously, the fact it just bent towards it, but what might we know about water, whatever? In the back row, please.
Water conducts electricity, so it like, attracts towards it and bends.
Okay.
That's why I said.
Okay. Jacob?
Water is a polar molecule, so it reacts to a magnetic field.
Okay. Anybody else? Yeah.
Water is not flammable, and it doesn't need a flammability sticker on the tube.
Okay. Well, that's pretty observant. See, we use all of our senses when we observe. So, yeah. And that's actually one of the reasons why I'm going to be moving this out. But this is actually one of those things I call my kitchen chemistry demos. And before I show you that, I'm going to move this out because I am going to be using some flames here in just a bit.
The other one has hexane in it.
But if I go over here to the tap water now and make a thin stream of liquid, I can then take the balloon, and if I put it near the water, you should see here how the water is attracted towards the balloon. And it has to do with the fact that it is comprised of polar molecules. And so we are going to get eventually to that point here this semester to talk about polarity. Polarity is actually the very last concept we cover in this course. Whatever it is, December 7th is the topic is polarity that day. So we kind of build up to that point to where we hit it at the end. Now the next question I have here for you is, you take a look at these balloons and try to guess which gas could be in the balloons. Now just put down one. There's many options. If you are talking to your neighbor and you think that they are different, could be different ones. Maybe one of you put one gas, the other neighbor puts a different one. What do you think could be in the balloons? Anybody need a syllabus before I go? Do you have a syllabus? So let's get your answers locked in here, please. And we're going to check out your answers. We'll count down 5, 4, 3, 2, 1. And so I see answers like hydrogen, carbon dioxide, helium, oxygen, neon. Ones that aren't possible would be carbon dioxide, gel isn't, oxygen isn't, but hydrogen and helium are possible choices. Now, what would be a good test to distinguish between hydrogen and helium? Flammability. And if you've had me before, you know that I have a little saying that goes something like this: if possible to test by fire, then do it. So what we're going to do is we are going to test by fire, but if you've never done this before, because I have one of these balloons handy, I have to do it.
Well, that is inhale some helium. I just love playing around with this stuff. You know, we sit around as chemists and we pass balloons around. Sometimes it isn't only helium, we got other gases as well. But what I'm going to do here is I'm going to check these out by testing by fire. And I've learned that I have to be careful about how much helium I inhale because sometimes I get a little lightheaded. And I've been told my lips turn blue. And I've never like passed out yet, but I mean, it's just kind of fun pushing it to the edge, right? Okay, so, oh, this is a lot more fun with the lights turned out. So we'll just turn these down a bit and maybe get this one out of here too. Now, if you get startled easily by loud sounds, and I think we're going to ask these 4 people to maybe just vacate like over here for right now, just because I like to say you're in the firing range. Okay. So we will go ahead and if you get startled easily, again, you can cover your ears. Somebody says this is like a Shamu show or whatever, you know, it gets splashed out in the front. And so there we go. And then if we go to the second one, we want to see what's happening with this one. Again. All right. So we go back. Oh, I think you can probably come back right now. No, wait, just wait. Which one was the first one, do you think? Helium. Second one? Hydrogen. And the reason why I say don't come back is because this one here is a very special balloon. Where is it? All right, now this balloon here is one that I took great care to make sure that I put the right proportions in there. And I put in 2 volumes of hydrogen for every 1 volume of oxygen. 2 volumes of hydrogen for every 1 volume of oxygen. Now before I do this one, I am going to put on some ear protection. And before I do it with you, I need to make sure that your ears are covered. And I can't do it unless your ears are covered, so again, cover them up. All right. And I always like looking at the dust that comes down here in the ceiling when I do that. So, all right, you can come back to, wow, see this dust? Pretty cool. All right, you can come back, thanks. So I do the house cleaning for the maintenance staff here, you know, a couple times a year. But now, we have hydrogen and oxygen, which of course, when they react together, what do we form? Water, yeah, water is what we form, and a whole bunch of heat and extra energy. So, and many say that what we just witnessed is going to be our energy source of the future. We'll be running around and we'll have cars powered by hydrogen using what are called fuel cells. And so when you go into the gas stations, you'll be gassing up with hydrogen. Rather than running it explosively like we do here, you'll be running it through fuel cells, which will wind up creating the energy in the form of electricity, which will then generate the power used to drive the wheels. So I don't know how far we are off with that. Obviously, one of the biggest concerns about hydrogen is its high flammability and its explosive nature. So, yes?
I think the lowest concentration that you can have hydrogen explosive in is 2% concentration in air.
Yeah, it has to be pretty low. Yeah, but there are ways that we're looking at different types of metallic. I don't know what you call it. It's not like a gel, but it's a very highly aerated stuff that you can basically force the hydrogen through to allow it to come through only as quickly as you need it to come out, and it makes it much, much less explosive. In fact, you can shoot a tank that contains hydrogen with this highly porous of hydrogen, and basically you'll just see a little fire come out the side of the tank, and it won't be the big explosion like you just saw here. So, before we go on to the other stuff, one of the things that I do like to ask then students from time to time is a bit about your chemistry background, so you can remind me what your chemistry background is, and I don't treat you all like chemists or whatever else. So, I am curious, have you previously taken a chemistry course at any point in your life? So we'll check your answers here. And of course, the answer to this one should be yes. If you put no, you've probably not read the prerequisites very carefully. You are supposed to have had some previous chemistry before coming in here. So in fact, one of the first things that we'll talk about here once we get to the content in about 5 minutes or so is that there's an expectation. We won't be covering the first half of chapter 1. That's going to be an on your own expectation that you've seen and done that stuff before. Okay, next up. What do you think the greatest predictor of success is in this chemistry course? Is it your previous background in chemistry? Now, you're looking at it from my perspective. If I see you coming in to this course and I want to predict your success, do you think your greatest predictor of success is your previous chemistry background or your previous math background? So get your answers locked in here, and we're going to count down on this. We'll count down 5, 4, 3, 2, 1. Turns out it is your previous math background. So even though chemistry is a prerequisite, even if you're one of those that were truthful in acknowledging that you didn't have a chemistry class, very often those students will do quite well in here as long as they have a strong math background. Now, if you're coming in here and you haven't taken chemistry and your math background isn't strong, I would honestly suggest, and this isn't just making light of it, that you do talk to me after class. We can maybe get you into chemistry 1020 because your chances of success in this class are not very good. We'd like to save you time and money in doing so. So again, your previous math background is your greater predictor of success in here. I am curious, how many of you are planning a STEM-related career? This one, there's no right or wrong. I'm just curious, and you might be curious of your peers. It's locked in. 5, 4, 3, 2, 1. And that's always interesting to note that some aren't sure, and there's a fairly healthy number of no's that are in there. How many are planning a career in the health sciences? By health sciences, that could be anywhere from veterinary to pharmacy to doctor, nurse.
Medical engineer.
Medical engineer, sure. So we'll check this out. Okay, about half of you are, half of you aren't. I bet I forgot to ask about engineering. So since I forgot to ask about engineering, I am curious, how many are planning engineering careers? Okay, cool. How many are in here just for your gen eds? Gen eds, how many in here just for your gen ed requirement? And again, this gives you a chance to see how you compare to your peers. Check this out. Wow, more than half of you. I have to say for 1061, that's probably the highest I recall seeing that. So that's kind of cool. Now, think of if you looked at the syllabus, you can look at it again if you need to. How many exams are there in this class, including the final exam? Don't hesitate to help your neighbors. Might see some of these questions again, at least this one, on your syllabus quiz. Get your answers locked in here. 5, 4, 3, 2, 1. And there are 5, including the final exam. 5, including the final exam. So there's 4 hour-long exams plus the final. Now, sometimes students will say, what are my chances of getting blah, blah, blah grade in here? So, just to kind of set you up on this, to say what is it on the average? What percentage of students pass Chem 1061 with a grade of A, B, or C? What percentage? Feel free to talk to your neighbors. What percentage do you think pass the course with an A, B, or C?
I think it would be 80.
Yeah, that's what I put too.
Maybe 70. I don't think so. It's 50 or 60.
All right.
We'd have to see if we really did hard class.
We'll check this out. 5, 4, 3, 2, 1. 70%. So we have 48 students in here. If you take 78% of 40, 70% of 48, what is 7 times 5, 35? So there'll probably be about 34 of you that will be left in here at the end of the semester that will receive C or above. Now, a lot of people come in here saying, well, I'm going to get an A. I guess I'd change that tune right now unless you plan to work hard. Some of you will get an A in here, and I'll congratulate you and be very proud of you. I'll be proud of my B students and C students as well. But you're not going to get those grades without doing some work in here. So I bring this up here because, again, if you look around here, there's going to be approximately 30% of you on the average that won't be here at the end of the semester. So think about that here as you get ready to do your work. Now, let's say I look at my most successful Chem 1061 class ever. How many students do you think? I don't know why there's 2 90s.
Can't be 90.
I think there's supposed to be a 70.
You think one or two can't be 90?
Well,
Maybe not 90.
I think A is supposed to be 70. But what is the largest percentage of students to pass Chem 1061 with a grade of A, B, or C in any one of my classes? And we'll check this out here. It is 98%. And I have a number of former students on my Facebook right now. The class that I have the most former students on my Facebook are from that class right there. I mean, I followed them. They are some of my most successful students ever, going on to get PhDs and careers as doctors and whatever else. So what I'm trying to tell you is don't let it be discouraging that only 70% on the average pass, because I've had many successful, very successful classes as well. And that was one of those teacher's dreams type of classes. For a given class, what is the smallest percentage of students to pass Chem 1061 with an A, B, or C? All right, we'll count down here. 5, 4, 3, 2, 1. And it was 40%. Less than half the class passed with an A, B, or C. That was about 2 years ago. It was one of those things that, you know, I went home every day and just, you know, felt like having a beer because it was just frustrating to deal with. I don't want you to be that frustrating class, okay? Because I like beer, but I don't like drinking it every night, okay? So make sure that you do your work, because when you do work, it makes my job easier, okay? When you do well on exams, it takes me less time to grade. And I like taking less time to grade. And I like, when I do it, I mean, I get chills thinking about it here right now, because I feel like I'm doing my job. And when you're not doing well, I feel like I'm not doing my job. I take my performance and your performance in here to heart very much, okay? So, this is your time to think. What do you think is one strategy used by students in my most successful class to date? What is one strategy? And we'll go ahead and show some answers here right now. Hopefully you're coming up with them. Basically, do your homework. Study. Come to class every day. Yeah. So get extra help from the tutors or one-on-one with the professor. So all those things are definitely part that will make you successful. All right. And it's something that I know that those students did in extreme. What I would say is that those were some of the busiest office hours I've ever had in my career that year. But I'm okay with that. I'm okay with it because, again, the payoff is I get to see your success. And let's just see if you learned anything here today. Which gas, when contained in a balloon, will cause it to explode with a big ball of fire when ignited with a candle on a stick? And if you want to talk with your neighbor just to remind yourself, then do so.
Don't they both? One's just bigger than the other.
Yeah. Sleep was a hydrogen.
And of course, that was hydrogen. That was the big one over here. Of course, which one do we give to kids today? Helium. Do we want to give them one with hydrogen? No. So the big ball of fire then was the hydrogen. Okay, now in your syllabus packet, you do have a periodic table in there. And mention very quickly here something about this periodic table. This periodic table is one that has a number of elements shaded in gray. These are the elements that you will be expected to memorize as a part of this course. And by memorizing, it's two pieces. You must know the correct chemical symbol, and you must know the name of the element with the correct spelling. I know for some of you spelling is a challenge. Unfortunately, it's a required thing in chemistry, because if we were to look at some things like, say we looked at these right here, chlorine, chloride, chlorite, and chlorate. Chlorine is Cl, or if we're talking about the diatomic element, Cl2. Chloride is Cl negative. Chlorite is ClO2 negative, and chlorate is ClO3 with a negative charge. So, simply by changing one letter, we convey a very different meaning about its composition. So does spelling count? Yes, it does when it comes to chemistry. Then the other thing that's going to make a big difference, first one here is cobalt. The second one is carbon monoxide. If I can't tell the difference in your case, it's going to get marked wrong. If you look at your elements, the first letter is always capitalized, uppercase. Second letter is always lowercase. So again, case matters as well. So your element quiz, I don't know when it's coming up. It's coming up down the road, probably in a couple weeks. You are going to be expected to know the atomic symbols there and their names with the correct spelling. The best way to learn those is by using flashcards, the symbol on one side and the symbol on the other. Okay, and finally, we are going to get down to content items here today. Looks like we're running a little short on time, so maybe we'll just talk about this right here. It is expected that you cover this stuff on your own. So if you look through, we are not covering this stuff in class, and it will be on the exam. So just because we're not covering it in class doesn't mean it won't be on the exam. This will be on the exam, and you are expected to know it. Okay? But if you had a previous chemistry class, this should all be common sense, whatever else, anyhow. So these are the topics that are covered in sections 1 through 5. Then on Thursday, we're going to pick up with this concept, and I guess we have just a little bit of time right here. I'm going to try to fit these things in. We're going to use the terms precision and accuracy. Precision and accuracy. As far as what these terms represent, precision here represents the reproducibility of a series of measurements. We sometimes refer to the uncertainty as, or the precision as the uncertainty of a measurement, while the accuracy is the how close a measurement lies to its true value. So the precision is the reproducibility of a series of measurements, and it's also called the uncertainty. And accuracy is how close a measurement lies to its true value. So if we were to look at these images that are up here and comment on the differences between them, let's start with image number 1 using these terms, or lack of these terms. In fact, maybe we'll start with this one. Which one represents both precision and accuracy? Number 3 does. Which one, if we look at this one, is this representing both of these or just one of them? Which one is it representing? Precision, right. It's very reproducible, but it's not very accurate. Okay? And of course, the first one then is one that is?
Accurate, but not good.
I would say it's very accurate. It's probably not very precise. If it's not precise, it's probably not very accurate either. Now, maybe on the average, we will end up showing that it's there, but probably not representing either one of those. Now, you could argue that it's perhaps accurate, but again, the fact that they're not very reproducible lies outside of there. Now, if we want to put this to data, one of the things that I like to do is to compare this to my weight. And I stepped on the scale this morning and came up with these values for my weight. And I have 212 pounds, step off, step on again, came up with 214, step off again, step back on again, and wind up with 213. So this was myself just weighing myself 3 different times today. And when I look at this, we could talk about the precision of these measurements or its uncertainty. And so these are results that actually we would say are rather reproducible. And we tend to think of them as being reproducible as long as it's plus or minus a relatively small number in the last digit. So if we talked about the precision of these measurements, what would we say that this precision would be?
Plus minus 1.
Right. So this value right here is referred to as its precision or its uncertainty, as plus or minus 1 pound. And so again, that's how we represent the precision, is use a plus or minus, then talk about the range around that. And then of course, if I wanted to express my weight, my best weight that I would present would be 213, and I would say that that's within a range of plus or minus 1 pound. So this precision here is this piece right out here, and of course the 213 here would be the average or the mean of those results. Now in lab this week, you'll just be doing the intro on safety, but you're going to be getting into spreadsheets next week. And when you get in there, you're going to be talking about some statistical techniques within spreadsheets. If you've used them before, and maybe you've talked about them in psychology, like standard deviation and such, you'll then be talking about how do we arrive at this plus or minus. I gave you an easy example to deal with, but when we're dealing with huge amounts of raw data, how do we come up with these values? And that will be a concept of your lab next week, and I think probably the week after. Now, on Thursday in here, we're going to jump into like section 6 or 7 in your text for chapter 1. I would expect that you have read through all of the first 5 sections before you come to class. You should have your calculator when you get to your next class. You must have your calculators. Finally, pink slips, get those to the center. I would like those from you. Write down your element if you haven't done it. That's what you're going to sign in every day. that's it. I do appreciate your attendance here today. I do love my job.